Assalamu alaikum wa rahmatullahi wa barakatuh. Hello my dear students. In this video we are going to complete lesson 2 unit 2 wave nature of light. We already studied the definition of light, the speed of light, and also the splitting or the analysis of white light. What happened to the white light when it falls through the glass prism or when it passes through the glass prism. For example, if I have glass prism, what happened to the white light when it passes through this glass prism? This is the white light or the sunlight, so it will separate into 7 colors. The 7 colors are called 7 spectrum colors, and these 7 spectrum colors arranged from red to violet: red, orange, yellow, green, blue, indigo, and violet. And also we studied that there is a difference between these colors in the frequency and in the value of frequency, wavelengths, and deviation. As we go down, what happened to the frequency? The frequency increase and the deviation also increase while the wavelengths decrease. Okay, so today we are going to complete this lesson. We will study another concept, which is energy of light wave. What does it mean? We have an important scientist, this important scientist called Max Planck. Max Planck proved what? Proved that there is a relation between the energy of the light waves, or the energy of the light waves is composed of energy. This energy is called photon energy, and there is a relation between the photon energy and the frequency. There is a relation between the photon energy and frequency. So Max Planck proved that the energy of the light waves composed of energy, light waves composed of energy quanta. This energy quanta called photons, and this energy photon of each color directly proportional to the photon frequency. What does it mean, photon frequency? That means if I have the frequency, or if the frequency of the color is high, that means its photon energy will be high, and if the frequency of this color is low, that means the photon energy of this color is low. And as we studied before, that if I have the 7 spectrum colors, the 7 spectrum colors: red, orange, yellow, green, blue, indigo, and violet. That means which one of them that has highest frequency? It is the violet, because I said if we go down, the frequency increase, the deviation increase, and the wavelengths decrease. Okay, so which one that has more frequency? It is the violet. That means which one that has, or which one is the greatest one in the photon energy? Also it is the violet. So when I ask you, give reason. Violet has or violet is the largest one in the photon energy, in the value of photon energy. Why? Because it is the greatest one in the value of frequency, and we said that the photon energy directly proportional to the frequency. Okay, also we studied that if I write to you this sign, it means what? It means proportional to. So instead of saying, or instead of writing proportional to, I can write this sign to refer to these words. Okay, so I can say the photon energy directly proportional to the photon frequency. Okay. Also in physics, if I want to emit this sign and put instead of it equal, that means I'd like to emit this relation or this sign and put equal. How can I make this? If I make this point, so I need to write constant. I need to write what? Constant. So I can say the photon energy equal what? Equal constant times photon energy. And to appreciate the rule of scientist Max Planck, this constant is called Planck constant. This constant is called Planck's constant. Okay, so what about the energy of light waves? Photon energy directly proportional to the photon frequency, and if I want to emit this sign, so I can say photon energy equal constant times photon frequency. Another concept related to light, the behavior of light through different materials. If I have different materials and I allow the beam of light to pass through these different materials or different medium, do you think that all medium allow light to pass through or not? Or in another way, do you think that the medium which allow light to pass through allow the light with the same ratio? That means some materials allow most light. All materials allow most light? No. We have three types of materials. The first type is transparent material. The second type is semi-transparent material, or I can say translucent, the same meaning. And the third one is opaque material. What is the difference between them? The first one, which is transparent material or transparent medium, it permits or allow most light to pass through. It allow or permits most light to pass through. So I can see the object behind it clearly, like the water, like the clear glass, like the air, for example. If I put anything in air, so it is easy to see it. Why? Because the air allow most light to pass through. Okay. Semi-transparent material, they are the materials that allow some light to pass through. They are the materials that allow some light to pass through. So the object also can be seen behind it, but less clearly than the transparent one. Okay, like the tissue paper. If I have tissue paper and I put the pen behind the tissue paper, can you see it? Yes, I can see it, but clearly, like if I put it in air, no, less clearly. Okay, the third one is opaque medium or opaque material. They are the materials that don't allow any light to pass through. That means we can see the object behind them. For example, if I put the pen behind the book, can you see the pen? No. If I put the pen behind your human body, can I see the pen? No. So the big material, they are the materials that don't allow any light to pass through. So the object can't be seen behind them. Okay. Another concept, which is the last concept, light intensity, and the same points that we say in the sound intensity, also we will repeat it again here in the light intensity. We defined before, or we say, how can I calculate the light and the sound intensity? I have here surface area or unit area. I can calculate the sound intensity by the amount or the quantity of energy falling perpendicular to a unit area in 1 second. Also, the light intensity measured by this way. So it is easy to identify the light intensity. It is the quantity of light energy. quantity of light energy falling perpendicular. Falling what? Perpendicular on a unit area in 1 second. In 1 second. Okay. So the light intensity, it is the quantity of light falling perpendicular to a unit area of a surface in 1 second. And also, as we said, we have law of sound intensity, inverse square law of sound. Also, we have inverse square law of light. The inverse square law of sound is the relation between light intensity and square of distance, and the relation between them is inverse relation. Also, the relation here between light intensity and square of distance is an inverse relation. So I can say the light intensity, can say here the light intensity, this relation is proportional to, and what is the relation between them? Is it direct or inverse relation? No, it is inverse relation, as I put here fraction, so it is inverse relation. That means the light intensity inversely proportional to the square of distance between eye and light source. Again, the light intensity inversely proportional to the square of distance between eye and light source. That means what happens when the distance, for example, increases to double? If the distance increases to double, that means the light intensity will decrease. But decreases to what? It decreases 4 times, because I say here square of distance. Okay. In the opposite or in another point, what happens when the distance between eye and light source decreases to half? If the distance between eye and light source decreases to half, what happened to the light intensity? The light intensity will increases, but increases what? Increases 4 times, because I have here square. Okay. I hope you understand all points that we studied in this video, and please study them well. And if you don't understand anything or any point, you can return back to me because I have homework on this point. Thank you for your listening. Assalamu alaikum.